Hi, welcome to Coffee Compiler Club. We have a bunch of new people today, so I'm going to do the full spiel. So this is anything to do with compilers and language runtimes and garbage collection and typing systems and nil versus not the nil and concurrency and language implementations or whatever. I keep an open mic policy. Ask what you ask. I don't have any set agenda. Conversation goes where it goes. I reserve the right to moderate. Never had to do it. I ask you to mute your mic if you're not actively talking, because we get too many people with background noise going on. It gets loud. You're being recorded live. Generally these days you get up on YouTube within a couple hours. If you don't like that, bail out now. I see we've lost Hayley already. And I guess that's the end of the spiel. So I will ask Micah to give us the 30 seconds of who he is and what he's doing, while we wait see if Hayley wants to join us again, or gets his name changed or his Zoom client uncrashed or whatever. Micah, you there?
Oh, hi. Yeah. Yeah, my name's Micah. Hi. I'm a student at Graal College, which is a small liberal arts school in Iowa. I'm from New York, and just like basically last year, I joined something like this, like at my school, a online club for Haskell, and like that kind of sent me down a rabbit hole of language implementation and things like that. And so, yeah, here I am. I still I'm learning a ton, but glad to just be able to talk to people or hear people talk about programming languages.
Sure. Welcome.
Sounds like you're in the right place.
Hayley, name here. It's your turn.
Hi. Yeah, I got my name fixed.
Oh, you got your name. There it is.
Yeah. I'm sorry for that. I haven't used it.
Don't apologize. It's all good.
I haven't used it for like a year. So anyway, yeah. So hi. This is my first time going to any sort of meeting. I've worked on, let me think, yeah. My first time in a meeting, I've worked on a SQL common Lisp implementation and a regular expression compiler. That's sort of the background. I just have incidental knowledge of compilers. Okay,
cool. Well, that's the intro. I'll throw out an AA yak shaving story, or cut it short because it was way too many yaks. I'm still shaving away. And then whatever people want to talk about after that. So I've been working on moving the theory part over to the practice side of the house. I finally got to my first real function definition. Had all kind of funny issues, went back and wrote the theory side of things that matched the test I was doing on the core on the main AA side. Hit something stupid, chased a bug down, hit something stupid, chased a bug down. I thought the theory side was pretty well tested. So I added some more asserts, chased another bug, discovered that it was all running pretty well, and it was still using the old proc. So this is like the first major yak shave. I have a place where I have to widen types to prevent infinite expansion. So like imagine you're doing a constant propagation analysis. You're doing a for I equals 1 to n. And what's the type of I? Well, I is an integer. If you're doing integer ranges, you might say I is 0 because it starts at 0. Then you add 1, you loop. Oh, and now it's a range from 0 to 1, 0 to 2, 0 to 3, 0 to 4 billion. It takes forever, right? So after a few widenings, you have to like clamp it and say, you're just a full width int. I'm doing the same thing conceptually with structs, where I loop and say, you've appended to a linked list, you've appended, and the list grows longer and longer. Then you have to cut it off and say, okay, and here there are one or many instances of the prior link type. And I had a good version of a prox, which gave me a true cyclic type out of it. I had all kinds of monotonicity issues with it. I backed off and went to a stupid one, which literally just cut the list off and said, and here I don't fucking know. Just to get other things sorted out, get my monotonicity back, get my strong typing back, get my whatever. But it was giving me a much weaker result, but I didn't care. I just got all the other theory bits worked out. So now I'm back around and said, why do I have this monotonicity problem? And the answer is I probably actually don't. It is the case that the cyclic approximator is not commutative with meet. Like A approxed meet B is not the same as A meet B approxed. So I was worrying there that was causing me non-ethnicity. I eventually decided it probably shouldn't. So I turned it on, ran into a bunch of other issues and things that I had changed that I hadn't gone back through the procs on. I cleaned them all up. And now I'm down to like most of my tests, like nearly all of them pass, except 1 or 2 are throwing an internal assert. And I've spent, and I found, 3 or 4 more new bugs of things I wrote last week. I don't know. So it's all week long. It feels like running in place, kind of, sort of, just to get the old new approx back running. Maybe it's there. I'm still got one monotonicity trigger that I highly suspicious I have something stupid going on, and then I'll claim, victory for the alliance, and all my core AA theory tests will all get a much sharper result because the core approx does the recursive approx does a much better answer. So that was my yak shaving. I've been yak shaving all week. No one else want to say anything now?
So in that system, if I have like a while loop that's asking for input from the user and then saying x equals x plus 1.
Yeah.
Technically, this is a big int because it could go forever because you could
Yeah.
keep giving user input of increment one more time before you say done.
Right.
But practically, a 64-bit is never going to overflow.
Right. But you don't want to do analysis 2 to the 64 iterations before you stabilize.
Right. Is there a structure to tell AA, hey, I'm pretty sure this thing is going to be a 64, but in theory, it could be a big int. Compile it as if it's an int 64.
I'm not
in
doing,
the event.
I'm not doing implicit big ints. You want a big int, you say big int. Your ints wrap. I'm doing 2 to the 64 standard integer math with wrapping in
So
the
if
theory.
I have a potentially infinite loop that's incrementing something, what type does that int get by default?
It'll go to N64, yeah, and be done, yeah. In the land of Hotspot, once I sorted that one out, I just set the expansion to 3, like I widen you 3 times, and then I say int full size. And all I was looking for with the widening was if you had an obvious use of a small narrow int, usually in a switch, where if I kept the range tight, I could do something smarter at the switch statement. People had enums they wrote in Java like you would write them in C, where you just did const int is 1, 2, 3, or 4, and that's all it ever is in this situation. And those would pick up with the range widening hack. But the for loops would run forever unless you did a widening thing. And so I count widened attempts in Hotspot. 3rd widening attempt, bam, you're done. You're a full size int. And I'm not currently playing ranges on ints at the moment, other than when I widen you, you'll widen by, I'm gonna say powers of 2. You'll widen from an int 8 to an int 16 to a 32 to a 64, and then you're done. It'll go pretty quick. So I have a struct widening problem is what I was hitting right now. And my theory is that I do my recursive approx, and instead of widening, I'll get you, actually it does, it has a cutoff. The approx guy says, how many times will I allow you to repeat the structure before I wrap it and say you have to be a cyclic type? And I just have a number there that I can dial a knob on, and it's currently set at 1.
In AA, is it possible to add a field to a struct at runtime?
No, it's strongly typed. That field has to be added at the code. So I'll know that this struct will have this field or not, even if you don't use it, or even if you pass it along to other functions which don't care for that struct or that field. They'll just ignore if it's present, and and if it's absent, they don't care anyhow. So your structs are strongly typed using, classic Hindley-Milner with record types. Why are you asking? This is like a JavaScript thing. Hey, it's a hash table. I'll just add another field.
Yeah, basically, I was asking the JavaScript thing of like, is a map a different thing than a struct?
Yeah, yes. My theory is I will boil a struct down to a wad of memory with fixed offsets for accesses. And
So if I've got something that looks like a struct, but then may also have extra fields, it's like, yeah, just make a struct that has a pointer to a map of extra fields. Like,
yeah, if you want to have a runtime that said, give me some more, yeah, you put a pointer off to some more, right? If you want to just have some structs have these fields and some structs do not, then I get two types, one of which is a subtype of the other. And then you can mix and match accordingly.
Do you have any plan for the C trick of last field in the struct being the array?
Yeah, I do.
Oh,
So
no.
one of the yak shavings I went down this week, in fact, was saying I give up on arrays as a separate entity because I want to have, as soon as I went to the place of primitives want to have their operators attached to them. So 1 + 2 was look up the plus operator on 1 and get the primitive add. Okay, fine.
So
Then you
now
wanna do
all
this-
your arrays are structs now?
Yes.
Oh, no.
So like you have a map call on an array. That makes total sense. So yeah, right. Now, have I implemented? No, I got rid of my old version of array, which was just simply a placeholder anyhow. And the hard part of getting rid of that is I get rid of strings, which were simply a placeholder, but I use them as a convenient, not a struct, not a other thing guy to round out the test cases and the like. So I yanked my strings officially. I have a fake string, which is a struct, which has one field called car0, which is the first character of your string as a placeholder, right? But then it can have things like the length of the string as a call, and it can have the uppercase and it have the whatever as a call. You know, all the string operators can happen on it now.
Well, and I assume that the first field of the struct is the length of the array.
Yeah, well, sortly comes the length of the array, and in the case of a string, you want a hash and a bunch of other things that probably show up there. I don't know what the hell I'm going to do. So that's a open question how that rounds out. But yes, the theory is that the last field of a struct can be an array that I'll just do the base offset plus your index afterwards. And then I throw all my functions on just like I've been doing with everything else.
And the question then is, how do you organize your array of structs?
Well, so an array is no. An array will be probably have a length field of some indeterminate size yet. Probably, I'm thinking variable according to very small arrays versus large ones, and then a sequence of homogeneous size things stacked out in memory, just like you'd expect, right? Okay, if you want an array of structs, you start with an array. That's your array right there, and the first, second, third elements point to structs as separable objects. Whether or not I go to the two-dimensional memory layout as a C thing is sort of open question. I'm not decided to go there yet. There is a theory that says I'll do the trick I'd figured out at Hotspot, 20, 25 years ago, which says we'll keep the headers for all the array of structs for all the structs, and they'll force the layout to be contiguous, and the array math just skips the headers, but the in-between objects look like objects, and you can do object things with them. And the garbage collector and the runtime will conspire that they stay locked in place in the whole array. And that'll give me sort of kind of the best of both worlds, except I'll have extra object headers. And there's a third theory that says I'll ditch the object headers and give you exactly what you just asked for, structive arrays, where the internal arrays are all, internal structs are all no headers, and I'll just have to do interior pointers on them. We just picked up, Max, I've lost you on my list. God damn, my new world order of maintaining visitors here.
Nice coffee mug, Max.
I'm sorry, what?
I said, nice coffee mug, Max.
Oh, I see. This
My mom
used
got
to
it for
say
me.
something 20, 25 years ago, and it slowly lost it all. How you doing, Max? And why can't I find you? There you are.
Thank
My
you. It's
found.
been good. I've applied to grad school and stuff, so things are moving.
Oh, excellent. Where'd you apply to?
Like 9 places.
Fine.
Oh, and it was
Where would
originally
you
like
like to
5.
get into?
The
Northeastern.
Western Air Temple.
Yeah, exactly. Exactly.
I'm
I'd like
sorry,
to
I
become
didn't
a
hear
software
Cameron.
monk, the Western Air Temple, you know,
Gotcha.
whatever the equivalent of an air nomad is.
Yeah. Pick the one that didn't get bombed to pieces.
Yikes. I looking at Northeastern, because like 4 separate people were like, yeah, you should talk to Jan Vitek. And I was like, okay.
Oh yeah, Jan Vitek's a good guy. I don't know, Northeastern's got a good rep, but Jan Vitek's a great guy. You know, Stanford's pretty good, Berkeley's pretty good.
Didn't apply to Stanford or Berkeley.
But Jan Vitek's a good guy. Yeah, he and I go long ways back.
Perfect. There you go. So talking to him and a couple other people, but it looks like it's going to be probably Boston.
Okay.
So,
Okay, there you go. You can say hi to Cameron.
say hi to who?
Cameron,
Oh, you're in Boston?
Kind of.
too close?
Lexington, yeah.
Lexington, yeah. Okay.
Close enough.
That's a T ride away. I think
That's
T
in
goes
my
out to
bike
Lexington,
radius.
right?
The T comes out to Alewife and then bike trail. Yeah.
You can bike it from there, yeah. In the 4-foot snow.
Oh,
I
you
had
can
my-
cross country ski on the bike trail sometimes.
Oh, cross country skiing. Okay, fine. I spent a year and a half in Boston. I had my fill of driving in snow.
So you don't want to
Don't
drive.
drive.
Exactly. Unfortunately, I lived far enough out that was sort of the major option. So that's fine. That was a long time ago. I was a much younger guy.
You can do what my buddy does, which is he bought, you know, the people who work in freezers all day for their jobs? They've got refrigeration tech suits.
Really?
He bought one of those and bikes around in it in the winter.
Really? Wow. Okay. That's getting hardcore now.
I mean, it's like $300, which is roughly the cost of, you know, a good winter cycling outfit anyway.
Yeah, I'm about to
Figured it might
say
as well
that's
be.
not out of control.
Yeah,
Right?
one of the Sun Labs guys here would bike from, I think he lived in South Boston, and he would bike to work in Burlington every day. So that's kind of like living in San Francisco and biking to
Sunnyvale.
Sunnyvale. Yeah.
Yeah, I was in Burlingame and drove
Every day of the
into
year.
Kendall
Snow,
Square.
whatever. Yeah.
Wow.
Kendall, I used to work in Kendall Square. One Kendall.
Yeah, one Kendall Square. Yeah.
I remember asking that Sun guy, like, when do you give up? Because I was biking to work. He's like, what are you talking about? And then I felt bad. So I started biking through the winter too. And like, no matter how much warm cycling gear I got, it was the wind that would kill you, because it would eat its way through. And I would get like frostbite on the tips of my fingers. It was too much, but I managed it for a few winters until I found out that riding on black ice sucks. It's actually fine until you try to turn.
Yeah. So Texas A&M, it's like fucking Texas, right? And it's College Station's kind of getting in the prairie. So, you know, winter happens, you get snow and ice, whatever. I'm whipping through campus on my bike as a 20-something kid, obviously oblivious, whatever. And the center fountain in front of like the library and a bunch of other stuff has been running overnight, and a hard winter storm had blown through and blown freezing. And the ice, the sculpture, the fountain had blown water that had turned into this gorgeous ice sculpture that rolled up and over the side and down. It was all frozen and big flowy things. I was just staring at it in awe, like, wow, this is really cool. And of course, I'm whipping around the ramp coming to the bottom, and it's just sheet black ice. And I'm coming around on a curve, you know, with good traction and good speed. Wham, down, slid, I don't know, 100 feet into the street, got all ground up. But it was really pretty till I face planted. I didn't face plant. I went sideways.
It was memorable.
It was memorable. It was memorable enough that I can remember it 50 years later. 40 years later. Oh, long time ago. Fine. Yak shaving. There you go. Max, you were asking me about Hotspot debug info.
Okay, so yes, I had this maybe fever dream about JITs the other day. And I'm trying to see if this is a thing that exists for real, or I made it up as like a combination of several different things that I saw.
Yeah.
Okay, I have a memory of some snippet of Java code that declared some compiler intrinsic with all of its guards and assumptions and whatnot. It's like 5 lines long, that the JIT could then read and be like, okay, I know how to turn you into just a muv. And it was just like the The thing that I'm looking for is the API used to describe all of these assumptions and constraints, and or like some IR description in Java.
Yeah.
And someone gave me something close in Graal. I think Chris Seaton and Stefan Marr gave me some close descriptions, but I haven't found the kind of example usage that I'm looking for yet.
Okay.
If anyone has pointers, that'd be great. I'm trying to boot up my computer so I can get on the Google Doc.
Right. Oh, I haven't even looked at the Google Doc. See if nothing's going on special there. Yeah. Okay. So fine. So there are a couple of places, depending on which piece you're looking for, that goes on in Hotspot. And none of it's in Java because Hotspot predates Java, obviously. The chicken came before the egg. So there's a thing called the machine description file, the AD file, that lists the primitives that are going to be emitted by the backend. And in about 5 lines or less, you can describe the set of registers the instruction takes, the register encodings. So that's not what you're looking for. And if you have like
it's higher level than that. It's like at the Java level. It may not be in Java, maybe in C++, fine, but it's like it describes the Java semantics, not the lower level machine stuff.
Is it kind of an IDL of sorts?
Kind of.
It's
like an IDL or a like small DSL for like
a macro DSL.
Okay, there's a piece not in Java but in C++ that we use to describe Intrinsics. We're going to do native C calls back into a wad of assembly that we're not talking about right here. Somebody somewhere says, here's a Java call, but when you compile it and it's a native, you don't make a native call to an unknown native wad. You're going to make a native call to this wad right here, except it promises to follow the rules. Because it promises to follow the rules, we'll skip all the native wrapper overheads and call this wad as if it were a piece of C code with the standard C API. So it has to play by the GC rules. It has to play, it can't block, it can't, a bunch of other shit goes on. That's floating around in C++ code. So a lot of things like you soft float for sine and cosine, because the Intel hardware does like half of a sine or cosine, but it doesn't finish the job for last bit precision and overflow, underflow cases, shit. So you call soft float the library. You call it floating point library. You don't need the wrapper. It's guaranteed to terminate. It comes back in good time. Doesn't meet GC issues. So there's some descriptor that says, and you know, this routine can be treated this way. That kind of thing floats around.
I think it was still higher level than that. I really think now I'm thinking it's not Hotspot. I think it's in maybe a Graal or some.
But Graal will do that, not Hotspot. Graal did Java and Java a lot of it. So they started with the JVM execution model, JVM running, and then they half wrote the compiler in Java and half did not, and they wrote subset of the compiler, I mean subset of Java and whatever shit. You know, they did some good games. It was all fine, but you had to have Java first. So that would be Graal.
Yeah, I don't know what this. I know I'm giving really vague, useless.
That's fine. I mean, I write compiler bits all the time, so I have all my intrinsics, all, you know, add, subtract, multiply, divide, eventually boil down to a one-line descriptor somewhere, and then they inherit from something that says, oh, you're a 2-integer input, 1 output, consistent types left and right, and you're the int version of the float or whatever, and then that inherits from, you're a primitive, some ints, some outs, some da-da-da, and that inherits from someone else. It gets in, and you have the following, whatever, fine. So you get a stack of inheritance, but your 200 odd short primitives that do something stupid and quick, min, max, multiply, divide, mod, blah, 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 all boil down to one line somewhere.
It's amazing that it takes 10,000 lines of code to emit a single add op.
Yeah. It's the right add op though.
Yeah, that does matter.
Yeah.
I wonder if it was
the right instruction.
Max, I'm wondering if it was a JNI thing you're referring to, because it kind of rings a bell from some of the.
JNI will do, but JNI get a native call.
I mean, it could be, because I spent like 2 years focusing on Python C API and I'm mistaking in that part of the JNI. So
yeah,
it's possible.
Yeah. Yeah, and the JNI needs to know what you're passing in as pointers because he has to wrap and unwrap them. And he has to know if you're synchronized to lock and unlock. A bunch of other stuff he has to know. He has to have your calling convention because he's going to do a native C call and he's going to do argument shuffle to match the calling convention.
So are you implementing intrinsics in your typed assembly idea, or is typed assembly implemented by?
Yeah, who you asking?
In AA, you mentioned that you wanted to have some kind of typed assembly.
Yeah. Yeah,
Is that the same as intrinsics, or is that different?
It's different, but one probably implements the other.
Yeah, that was my question. Is it more intuitive to go one way or the other way, or does it not matter?
To get started, I'll have intrinsics that no typed assembly, it's just intrinsics, just to get going. Then, like I've done with the int wrapper game that I played last week and the last 2 weeks, I'll probably come along and say, wow, if I had a typed assembly, I could replace a lot of this shit with a canonical typed assembly. And then I'll come back through and say, make a typed assembly work, and then go replace whatever primitive games with typed assembly for final emission of bits.
Yeah, we did it the opposite direction. We did the typed assembly with no intrinsics.
Ah, I see. It's not a bad answer.
It sucks to implement, but I mean,
Yeah,
the first one. Yeah.
Actually, that's true. If you're not self-hosting though. What are you having issues here?
No, I'm saying to get Hello World, it took us almost 2 years to get a Hello World to run.
Oh, because
because we had to bootstrap the entire because you have no intrinsics. You have no.
Gotcha. Now I get it. Yes.
Yeah, Hello World took me like 4 years. Although the first 2 years I just kept changing stuff and wasn't really sure what path to take.
Right. That's where I'm at. I'm 2 years in and I'm still changing things. And
yeah, I'm currently 7 years in
now.
almost. And I think this year might be the first year that it's going to be actually useful in some way.
Oh, excellent. Excellent. Yeah. Yeah. I found myself on this Discord channel. How do I send you guys a Discord channel? /r/
Programming languages.
Programming languages. Yeah. Well,
yeah,
boy,
it's from the subreddit.
Like screwing around trying to make toy languages left and right. It's kind of fun.
No, the Discord and the subreddit for those, I'll link it.
Yeah, I found the subreddit to be a little slow, and the Discord was more active.
I think it's okay if you only have 1 or 2 posts a day. Like, you don't need to be, inundated with stuff all the time. If you're like,
okay,
oh,
fine.
Your project, that's a nice morning coffee read.
Yeah, right, fine. Okay.
No, right so the subreddit is, I think usually it's a bit more academic oriented. So there's a lot of questions where, I read them like, I understood some words.
Right. No, the
Discord is a lot of people just hobbying around, basically.
Well, but there are some hardcore theory hobbyists floating in here. And you go to like the theory side and holy shit, I can't understand every third word. Yeah, here's, let's see if I can find, that's the parsing theory. The other guys are doing F# type theory versus God knows what. These guys are doing parsing right now. I was gonna find a quick example. It's fine. It's just like category theory and umpteenth order lambda cube this, that, whatever. And I'm like, okay, not my cup of tea. But then they had like back end shit, front end shit, which I totally get. Hey, look was like, cool project doing some random thing or another. Kind of fun to read through. Fine. Was all good. So when you asked me, Max, I thought you were talking about debug info, which was Hotspot describing OOP maps and machine architected state. So you can unwind from JITted code back to the Java architected state.
I see now how my text got you there.
Okay, fine.
What is the name of the way to encode JIT assumptions or guards in Java and Hotspot?
Yeah.
So that makes sense now.
Okay, fine.
But I'm looking at this So what we're doing for context is we have some type specialization stuff where you say, like, if you're doing a generic subscript operation, but you know it's a tuple, compile it into a like a field load and then an array load. But the way the type inference works, or the flow typing or whatever, you have to register that you needed that to be a list for this to happen. So if something gets eliminated, like the thing that caused it to be a list can't get eliminated.
Okay.
So like if something
this
refined
is Python
the type,
or
huh?
This is Python or PHP?
This is Python.
Python. Yeah. Okay. Yeah. Okay.
So we're adding
another
some kind of
Python
like
optimizer
API for encoding assumptions in. This is in C++, where you're like, if it's a list, and that thing will automatically add the we need this to be a list assumption.
Right.
But I'm gathering.
And what happens if the developer lies to you?
What do you mean?
They say, I'm assuming that this is always going to be a list, and then it's not.
Oh no, this is only inside the JIT knowledge. So this is like, we do have a mode that's more C#-esque where you can, or Java-esque where you can say this is a list and it's definitely a list and that it's been proven to be a list. But the normal Python mode is like, if we've inferred it's a list via an inline call, or like there's a list literal or somewhat whatever,
right,
then it's definitely a list and we can assume that.
Right.
Or it's like a global that was typed and whatever.
Yeah. So in the land of Hotspot, I just had a strongly typed internal IR and inlined everybody. If you wanted to know it was a list, it was in the typing system for the list. I mean, we would ask the type of this thing, hey, and he would say, yep, I'm a this or that, these interfaces and that base type and whatever.
You know, in my day, we didn't have types, so.
Yeah, fine. Yeah. Well, that's what you get for playing with Python.
In your day?
Yeah, I know. Yeah,
1992?
Fine.
Max, some of what you described sounds like method handles code. It sounds like the mutable call site. It sounds like the guard with test invoker and the switch point class. Any chance that's what you had been looking at?
Maybe. I'm just looking this up on Google. Do you have a specific link in mind?
Yeah, give me a second and I'll dig one up.
Sweet, thanks. Also, it turns out the inliner seems to work, and the usef to free that I've been chasing for weeks, which is why I hadn't been showing up in this call, was actually a 20-year-old CPython bug, so we're good.
I had about 5 years ago, I got a shout out for a bug that I wrote 20 years even prior from that, in the first core version of Hotspot, where I took some abstract data type thing I'd written while in grad school, brought it over, ported it from 16 bits to 32, and then put a comment in there that says, this hack is cool and runs a little faster right here and now and won't work on a 64-bit machine. And I let it go. And, you know, I totally forgot about it and had been there forever and a day. And of course, Hotspot eventually got recompiled to 64 bits. And it was a hash function lookout. And you only failed if you had two things that hashed within exactly 4 gigs of each other. So the 1 bit was off. It was only checking the low 32 bits and not all 64, which meant you had to have a really bizarre collision, and then it blew something, decided you were CSEing 2 nodes together in the graph that were not supposed to or whatever. Anyhow, the failure rate on this bug was like once every other year across all of Java VMs. It was an insanely low rate. And somebody was tracking it forever, and they finally tracked it down to, and here are these things CSD'd, and what the hell, the hash function's broken, what the hell, and stare at the comment. And then there's a comment right in the code that I wrote as a grad student. And this will fail on 64 bits, but that's 20 years away. I don't care. Dun, da, da. I live to see the day. Oh, excellent. But it wasn't my problem either.
It just reminds me of, you know, to-do comments, basically. I've had far too many cases in well, history in general, where you look at some code and there's some comment like, to do, and then some name from somebody who no longer works there. And it's like, yeah, we should probably fix this. And there's like a link to an issue.
Yeah.
Where you open it and it's like, 7 years old or something. You're like, great, thanks.
That's why you need the button that says, given this stack trace, find me the closest to-dos to the call sites.
Oh, that's an interesting one.
Dan, would you mind sending that to the Google Doc?
I'm
going to open that.
Which points? Oh, God.
It's one of the reasons we made to do into a keyword.
Into a keyword?
Yeah.
Ooh, really?
When it hits a to do, it throws an exception.
Oh, no. Okay. I was going to have ... to be my unimplemented, untested, whatever, unimplemented. And to do still in the comments, like IntelliJ pops up and says different color for to dos. You can hunt for them. He sorts them, gives you the list and shit like that. But I wanted something quick and short because right now, all throughout AA, there's code that says throw an AA.unimpl. It's like way too much ceremony because I'm only writing them when I'm writing fast and furious and I want to deal later. And so that's the one I want the shortest possible, get it done and blow an assert or fail when you hit it, but move on.
And since we can delegate entire interfaces to another, basically pipe it to another reference, we can use to do as an expression. So you can delegate an entire interface to do. So you can mock something and then fill in the methods one by one as you hit them.
So if I make a function that returns a ...
Right.
Should it blow up? When should that blow up? When I go to use the value that got returned? When I reach the return statement in a running program? Or if the return's not dead?
Yeah, I have ... as a, not as a value, but as an execution point that throws a panic assert. What I heard you say
like a thunk?
You can thunk it, yeah. It's not a thunk, you can thunk it.
So if I try to say return ...
Yeah.
If I reach that statement, it will then throw not implemented.
If you execute that code, so ... is executable code, just like Java, you said throw, right? So I say some sort of question mark predicate, blah, 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 that's all good, colon ... I didn't implement the ... If pred is false, I'll blow. Now I can thunk that, and I can just put a, no argument thunk that says, blah, colon ... whatever, ... Oops. So just put curlies around it, it's thunk now. Now I can return a thunk. If I execute the thunk by just, put a pair of empty parens after, say, call the thunk, and it can blow then. You can thunk ... but that's just the same as thunking throw and unimplemented. So there's a thunk for ... But in Java, that would just be a no arg function that throws unimplemented.
Yeah, I would be tempted to also have a sort of bang, bang, bang flavor that's like, this must be dead. If this branch of the if is not dead, don't even compile.
Okay, so a compile time, this must be dead. So that's an assert.
C has that, it's great.
I don't have an assert syntax sorted out. I like asserts. I use them all the time.
How do you do it in C, Max? Which one are you referring to?
I lied. It's a GCC thing, but if you can have this like attribute must be GCC attribute.
I think there's a semi-standard pragma for that type of thing, but I can't remember.
It's not a pragma. It's like an attribute, and you mark it that like the function must be inlined or the function must be whatever. Let me find the list.
Yeah. Like I fully have an intention of must be inline. There's a couple of those that for performance reasons I want to have must be the following things, like you're using an int like it's a wrapped thing, like a capital I integer in Java, but must be inline so that the capital I goes away. That's one of the compile typing asserts I want to have. It'll be a type error if you fail to be able to inline it away.
I think I found it, maybe.
Okay, so this is like a fail.
Yeah, the error. There's error and warning at compile time, yeah.
Yeah, that looks good to me. Right. So bang, 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 meaning this shouldn't, I should be able to prove this doesn't happen. Or I give you a compile time. So not an assert, which is a runtime error, compile time. So this is
Yeah,
what
compile time error.
Actually, I like bang, bang, bang. Which means if pred is not proven.
But that's one of those, what's it called? Not trigram. It's one of those C things. That, like,
yeah, I have to be
predates me.
careful here because it has syntax issues for bang, bang, bang. Like right now, bang's a not operator. 3 knots in a row is fine, except there's nothing after it. So now what do I take it as a token? Is it a special token actually, or is it, you know, some sort of operator call? There's nothing to operate on, so it's probably a special token. I have few enough special tokens in the language, but you know, that's a reasonable. So that's a variation on a runtime test. It's like fail. In other languages, you would say, you know, if not pred, fail. That you'd want to guarantee that it happens at compile time. That's not the right syntax. It's a pound of fine fail here. I don't know. I'm not doing the right thing. Something like that. That's what you're looking for. Which I like that. That's a totally same thing. Like
C
have a
was way ahead of it.
So is that a
way ahead of
legitimate
the game
definition
with the
for
Hotspot.
assert? An assert just becomes a user-defined statement? Or
yeah. Like I write asserts all the time. I want them to look like an assert. So there's a rule or theory that says I'll arrange some kind of syntax that it looks sensibly like you intended to be an assert, but the obvious way to do that, it's a runtime test that if fails, it hits the ...
yeah, so that's just a standard library function. It's not needed to be part of your language.
Exactly, right. But it's a common thing, and I want people to write it commonly. So in the end, it wants to be obvious that you're writing an assert and short to write. Like assert as a word is probably the longest I want you to have to write. ... standing alone, but you need the test is like an assert, but you didn't say assert. So there's something that says there's a code, common code, not smell, common code style that says if I did test question mark ... that's the assert. Or there's some other way to flag it, obviously, as this condition must be true at runtime. And bang, bang, bang is condition must be true at compile time.
One question. With regards to the compile time asserts, if we have a language where we can't, say, just stick any old expressions at the top level, say for example C, for example, mentioning that, and we want to detect some configuration is invalid at compile time. Say for example, you have a compiler and now you're telling it that it's working on 6-byte words. It can't work on 6-byte words. I don't know why you're doing that. It should fail at compile time. I don't know why it's configured at either, but anyway,
Right.
That's the situation. So like, how would you
right, so C++
that?
has like pragmas called for fail, where I wrote if def pred fail. It's not the right syntax, but there's some similar syntax that says if def something, and then what goes in the pred is a constant expression, which the C++ compiler will boil it down to a true or false, and then it will fail, which will give you an error message at compile time or not. So I don't have the right syntax here. There's something similar to it that says constexpr goes there.
I found a thing that I was talking about.
Okay.
It's in the doc.
Docs off to the side so they're not in front of my camera. Guard with test. Oh, invoke handle? No, there's more going on here. What do you guys?
So how do I say something like constexpr in a reasonable way? This must become a value at compile time.
In AA? I probably will put some tag information somewhere that's going to say it has to be folded down to a const. I haven't figured that one out yet. Something to do with bang, 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 or ... that says it's going to be folded up or not. Final assignments in structs that don't have constructors for the value, whatever, will have to be boiled down to a constant.
I mean, in theory, you could have some kind of is literal or is compiled down to a constant.
Yeah, but
someone could
these
just
are
write an if
things
statement that says, if this is literal, bang, bang, bang.
Yeah, these are things you want to have shorter. So I'm thinking shorter syntax. So here somebody's wrote some asserts as a function definition. So here's one where I'm expecting this to be, and you know, there's no good here. Constexpr. I don't. Where the bang is a bang assignment. You know, must be a const compile time. I don't necessarily like that syntax, but I'm throwing out something other than using a constexpr keyword. Like, what does C++ do here? They have constexprs. They have places where they know they're going to have a constexpr, or one is allowed, one is not allowed. If it's not allowed, what does it do? How do you say it must be a const? I don't like unequals as a, that looks, I can't actually probably do that one. That one's going to just be a Boolean test. That's not the right syntax.
Have some intrinsic that's like is constexpr.
Yeah, well, the is one says I'm asking a question. Did I get a constexpr out? I guess this gets to like C++ things that are like size of and type of that you get at compile time or typing time. And that has, if you say is constexpr and then you do this or you do that, the constexpr has to boil down without the constexpr. Like if I do a recursive thing, you have funny issues, or I'll declare that you can't get a constexpr from a constexpr in a recursive self cycle. Right? Write factorial where
I mean, you could have limitations of what can be done at compile time.
Yeah, what's done?
Like I think in C++, if you use constexpr, you can't do trigonometric functions because it doesn't know whether the place you're compiling has those instructions.
No, because the compiler has those instructions. So that's not it. So the compiler itself can run all the code it can emit. So if it can emit a constexpr, sorry, a trig function, it can execute a trig function and then just do the constant folding on the spot. Like I'm trying to say something like, I want to know factorial, you know, is const of some sort of factorial is defined to be a function that takes an x and does, you know, x1, or it's fact of x minus 1 or whatever the hell. I don't have the right syntax here. And I'm looking for putting is fact somewhere in the middle here. So you can ask, you know, fact is const of 3. But if I say fact is constant of 99, I'm going to say, you know, not a constant, but fact of 3 is a constant. And what's the limits? And I think that the story there is sort of, you know, the is const guy allows or demands or will unroll a limited count. And I know C++ tackled this problem. They'll let you do some things like, you know, for loops that are is const for I equals 1 to 10, and he'll just unroll it 10 times and then do the math and be done.
And C++ got a little bit out of hand because they said, okay, we'll do some tree walking evaluator. Okay, that's not fast enough. We'll have a bytecode evaluator for your C++. Okay, that's not fast enough. Now we have a JIT. And so you have a JIT in your ahead of time compiler to make the constexpr faster.
Really? I did not know that. And
There's
what's the limits
PhD
on
project.
what you'll do in a constexpr?
Sorry?
What's the limits? Like, your fucking JIT won't pay off unless you're executing looping, you know, 1,000 times.
A lot of recursion.
Right. Okay. So they do allow sort of arbitrary recursion. Somebody says this has to be a constexpr.
C++ templates and stuff return complete.
Oh, I knew that. Ah, geez. Fine. Yeah. Holy crap. What's the C++ syntax for saying this has to be a constexpr? What did they do here? Go ask the interwebs.
I think it's the keyword constexpr followed by the function call.
Yeah, okay, it's a keyword. It's a big one. Yeah. And you throw it on your declaration somewhere, and then the expression gets evaluated to death. So that would be constexpr foo is equal to blah, something horrific, right? I'm not
I
going
might have
there.
misspoken. I don't know if the JIT exists yet. I think someone was just talking about how they wanted to see it based on this bytecode interpreter, and they were designing it with that in mind. But I think it's just bytecode right now.
Fine.
So what
there's
should
no end to
happen
that
if I
one.
say constexpr read from standard in?
Yeah.
Do I read
Right.
from standard in on the machine that's doing the compile, or do I say no, standard in is a thing that exists at runtime?
I can't.
I don't remember what language this was. Maybe it was Rust or something, but you could do that. You could pipe into the compiler, and then it would substitute that into your program.
Wait.
Yeah, Rust sort of does that. You have compile time macros that, for example, read environment variables. And they're typically used for building like C libraries and that sort of thing.
But
you
they'll
might
read
have to read
environment
like path.
variables, not standard in.
I think so. In regular macros, you can't do that. And I think standard in is not marked as a const expression yet. However, you can have procedural macros, and those can run basically anything. They can, because it's basically just a plugin that runs at compile time, and then it spits out a certain data structure, and the compiler's like, okay, we'll just stick that in the AST. So you can have a compile time macro that calls to the internet and says, oh, it is 2 minutes past 3 o'clock. Nope, I'm not going to do it.
Okay, well, the other side of this is you could have, like, how Cliff's allergic to like build systems, so he's got a make file that downloads jars. You could have your macro system download your dependencies and cache them.
Seems like a reasonable enough to put in a build RF.
I'm allergic to most of the modern build systems because they do shit.
Sorry, Java build systems.
Doesn't make any fucking sense to me. Yeah, it's not Java, because the build systems in question will build all kinds of shit. They just do it. Never mind. I don't want to start that rant again.
But I do like the idea of, instead of having a make file, having a file that is code in the language.
I've done that.
Make is just a library that ships with the standard library.
Maybe. I've done that in the past, and like I said, it worked great. First thing the build system did was test to see if it needed to build itself, and then carried on. In fact, I built Hotspot that way for the longest time at Azul. I had a startup one-page make and a one-page shell script that between them built themselves, and then built all the parts in staged order that you need to build the JIT and VM and everything else. It was fast, it was furious, it was fairly simple to understand what was going on.
Yeah, generally, if you're not going outside of the language, why would you ever need a build system at all?
Yeah, and
the
the answer is that
tends to be orchestrating across multiple different separate technologies. Like, I'm building this in Java, then I'm doing this part in C, and then I've got to do something with Kubernetes.
You're doing Java doc
plus Docker,
like
plus I'm going to build a Linux image, and I have to tar something, and it's like, okay, so I'm producing 12 terabytes of stuff, for this hello world.
Right. The point is, you got the point right, though. You're outside of the language proper. Like, I want to bring a jar in from Maven. So I have a dependency somewhere in a build system that has a one-liner that lists a jar name and the semantic version number.
Yeah, but why in the build system?
Maybe for Maven. So this would be moving I went and got the jar into the language as opposed to the language runtime. So if it moved into the language runtime, I'm okay there. But so how many things do you move into language runtime? So I'm building an R piece which has docs for CRAN as well as an R executable. I'm building an R front end to hook to H2O as a big data thing. I have a Python front end. I build Python docs as well. I build, the web page backend online docs and shit like that goes on. They run through Doxygen, they run through this, that. There's 15 other utilities I'm running and building at the same time, all outside of Java, outside of H2O, and they're interfacing in. So, build systems go outside the language proper. That makes sense.
Right.
And which means they're more like the OS and less like your language.
Well, they're more like a bash script. Yeah.
Yeah, right. I want to do things at the OS level, sort of, kind of. And I can do that in my language, and I can make it convenient to do like Perl does. It's super easy and convenient to do in the Perl language, all kinds of OS-y things, like shell scripty things. not claiming Perl syntax is lovely. It's not. So write only code, fine. But you can imagine a way that you can do build like things in the language, but you're calling outside of the language all the time. You just have a nice wrapper that gets you to the OS easily. I think that would be a very good, useful, convenient, blah, blah, blah thing to have. And imagine, I can quickly imagine lots of use cases for it and lots of easy ways to get there. Actually, now that I've thunk about it for 10 seconds.
I found
You want something that's lighter than sys.os.eval.
Yeah, but you have to have the OS. So there's an os.eval, but then there's .ls, right? There's sys.ls or os.ls, os.cp, current working directory, print working directory, blah, blah, blah. And these things are all just obvious functions that query things straight out of the OS that are obvious file system manipulations. And then things that do like wget and internet webby things, all as short lead-ins inside the language that everyone can get out right away. And immediately you can do all kinds of scripty things with fairly strong typing and file timestamps or internal ordering things. And suddenly you can build a make-like utility in a few lines of text inside your language. And that might be a useful way to skip having an external build tool. Zombie Raptor?
Yeah, so that's someone's game engine, and they've in Common Lisp you can just write eval when, compile time, run the game, which is probably the most boring way to make a compile time game. But
okay, no, I'm not looking for compile times that are Turing complete or compile headups.
I mean, the JIT would help with that though.
Yeah,
yes, but that's the whole runtime thing. That's sort of, we're off on a dynamic runtimes now. It happens.
Yeah, I'm never going to use a make file that doesn't have a JIT.
But yeah, the macros are and Common Lisp macros are just plain old functions that the compiler calls at the right time. So those do get the native code treatment. Which reminds me, I should have mentioned with regards to the templates, the bytecodes, and the JITting, when we do bootstrapping for the SYCL compiler, which is a new Common Lisp implementation. No, okay, so it's like, so we run the compiler on the code. So yeah, for bootstrapping, well, we have to run the stuff in the host. So basically, we get the code, source code, AST, then we go to the IR, then we interpret the IR in the host. I think that's how it works last I checked. And it's interesting because you can apply optimizations to it. Sometimes the interpreter goes a bit faster, sometimes it goes a bit slower. I can tell you that if you do a very simple alias removal, it's like if you have X is 2, Y is X, that sort of very trivial stuff, where you don't even have to do a conversion to SSA or anything like that, it will go a bit faster, about 10% faster. I've been working on global value numbering, and when I do that, it doesn't actually go any faster. The GVN is just a bit too slow for that.
All depends on your cost to do and what you expect a trade-off for.
Yeah.
In a large Java or C method with lots of inlines and heavy optimization when we apply, global value numbering is a useful thing. In a small, narrow scope, you'll never have enough repeats to be bothered with the cost to do the GVN versus the gain you get out of it.
Yeah, I think, I remember doing some other examinations on the bootstrapping. Like I wanted to have a stab at looking at read barriers, write barriers. So what I did was I instrumented the interpreter. Every time it hit a read instruction, it would bump one counter. Every time it hit a write instruction, it would bump another counter, right? And the numbers were quite small. I think what I figured out was that, when we're running things in the interpreter, I think most of them were macros pretty much, which are, most of them are just a pretty functional style. It's just like, you get these arguments, put a defun here with this, and this. they're very quite trivial. So not much is actually run, which is probably why doing sophisticated compiling doesn't make the bootstrapping any faster.
So if you're running in an interpreter, you should expect at least half of your runtime going to dispatch inside the interpreter. That is, JITting anything trivial and getting rid of the interpreter dispatch loop is probably worth 2x without hardly blinking an eye.
Yeah. I think we use a chain of closures technique, which is, I mean, we get function calls instead of the dispatch.
Yeah.
And I mean, I've messed around with chain of closures. It's okay. It could be better, but it's a bit better than dispatch, I think. I can't remember exactly.
I'll bet you ditch the chain of closures to doing the parts in line. There's another 2x there.
Okay.
Yeah. I did a long time ago in a land far away. I did a fourth thing, and the basic fourth implementation was you had a list of words, like a chain of closures, that you would go call off to go do the thing, and you'd come back. And the dispatch logic was grab this address and call it. And then when it returned, grab the next address and call it, except that sometimes you had to, the call would change your return so you could jump and the conditionals and shit like that. Moving to a model where the instruction that you were calling the list of addresses had the 1 byte x86 call instruction op in front, and they just called in a row instead of you grabbing and calling and going back and forth. That was well more than 2x. Then go into the version where all the ones that were 5 bytes or fewer were inlined on the spot with nops to fill them out to 5 bytes. That was worth like another 40–50%. It was like another big ass jump. So there was a lot of these things that are like stupid, but all your time goes into bouncing around for the dispatch, whether you say chain of closures dispatching or versus inline versus call out, whatever, that's all your overhead. So you want to get the lower level, you're looking at lower again. And once you get rid of that levels of overheads, then you can start looking at classic optimizing compiler techniques like global value numbering that will have interesting payoffs. Like all these things have like these powers of 2. We have to take the big power of 2 first, then you get another power of 2, and then you get another and another and another and another, and suddenly you're talking real money. Suddenly you're looking like, hey, I'm getting competitive with C or Java or some shit. But you got to start by getting rid of the big numbers first.
Yeah, right.
Those are big hits. I mean, they're in terms of engineering time and effort and whatever.
Yeah. Well, yeah, this is just the interpreter that's used for bootstrapping.
Yeah,
so
well, maybe you don't care.
To be honest, yeah, we don't really care. Because we've got to dump an image in the end, so we have to run, the rest of the compiler. And ideally, we make optimized code. So, when you start the image, voila, you've got fancy code now. You don't have terrible code that we just fed to the interpreter instead. So yeah, I guess we're doing GVN not to make the interpreter any faster, but when we spit out the actual code, we get that to go faster.
All right, I'd have to see which pieces that you're looking at. It's fine. See you, York. Certainly, Hotspot starts up by JITting, if you will, the interpreter itself. And then he makes a custom interpreter for the hardware you're on.
Are you talking about the template interpreter? Because that sounds, JITting that sounds, that's a stretch.
Yeah, JIT's a funny word for that, maybe. He's a big pile of if-def C code, and he makes a lot of decisions about how he emits the interpreter at startup time, based on the hardware you're on and based on like the rev of x86 and all kinds of stuff. So your 32-bit or 64-bit VM, your small heap, big heap, your 32, 64 heap, there's like 8 or 10 first level, top level decision he makes. He changes how he emits code. And then he slaps the interpreter out before he runs any bytecodes. And then he just runs things normally after that, which means he runs a million bytecodes before main, which triggers the JIT on the shit before main and stuff. But I'm not trying to cook out a non-compiling binary after we're done. That's a different piece. I've done that too, and you had to make the call between when you emitted code and when you emitted bytes that you were going to interpret. Theodore, you made it. Yeah.
Hey.
Try just throwing people in. What do people think about me putting the attendee list in the doc? So your name shows up, or your email, or some variation thereof.
Let's not do email. I get enough spam.
Let's not do email.
Okay.
Yeah, great.
So I don't have everyone's names necessarily. Some
I
people I
bought
do.
5 car warranties this month. I don't need any more.
Geez, if they're showing up in your spam, life is good. I get fucking 5 phone calls for car warranties.
What can I say, Cliff? They've been trying to reach you.
Yes, they have. Holy crap. That and the Chinese voice person trying to get me to call, you know, them instead of whatever, the integration people. Somebody's trying to sell me that my IRS is out to get me, and I don't know. Some Nigerian princess wants me to save her.
Yes, my social security was revoked.
Yes, excellent. You gotta speak that good Chinglish there, right?
Oh, yeah. I keep getting calls about someone buying an iPhone with an eBay account that I don't have.
Excellent.
I'm just like, they're just like, an iPhone, $500. Like, geez, that's good value. They're very clever doing that.
Yep.
And they hang up on me. And they call me again. I do the same thing. They call me again. I do that. I do the stupidest shit when people call me, and they still call me after. I don't understand what they're trying to achieve with that.
No, I just hit the whole block button and move on with life.
These people call my grandparents pretending to be me or my siblings or my cousins, and they're like, help, you know, I'm stuck in Italy or whatever. I don't have any money.
Nigeria.
We call our grandparents something different than like grandma and grandpa. And so they're always like, young man, you should be ashamed of yourself. Like, this is a scam. You're trying to scam old people out of money, and then they hang up. It's like,
Two them out.
We got them out of one.
Excellent. Excellent. Yep. All right, are we done ranting on spam?
Okay, so I have a question. So do you think that Java as the implementation language for your for AA is like helping you or hindering you? Or I mean, I obviously you know about Java a lot because you've written it.
It's there because it's a language I know and comfortable with, and I'm just getting an implementation up and going. I need a rock solid implementation under my feet that I can change and mutate and hack and debug. The debugger's solid and everything else, right? So I don't need performance, so I don't need C. Not right now. Some point I need performance. Right now I need stability and ease of hacking. So you could argue I should have picked Kotlin versus Java, but you know, I'm up to Java 17 now, and it's, you know, it's pretty reasonable. Got a lot of fun features that I wish I'd had back in the day that, you know, that make it easy to use. And then
I know last time, for example, like someone pointed out, you know, you had written like, you know, char at 0 instead of char at 1 and stuff.
Yeah.
I don't know.
Well, that was me like whacking the operator. So the count of times I do char at is limited to like 3, right? There's a lexeme parser, which is looking at the 1 and 2 character lexemes I got floating around, and he plays char at games. Like here I have the parser says, you've done an open curly, I require a closed curly. So I hand you a closed curly string, and somewhere down the guts, he says, give me the first character. Is it match the 1 in the buffer? If it is, yes. If no, I'm going to fail and say syntax error. So there's a couple of those char ats. The operator one was like, I've declared some kind of operators, or I've parsed a thing which looks like it ought to be an operator. I have certain rules what the operators apply to. I go check the rule. Is this valid as an operator? So like there's like, and so as soon as there's like 3 of those places, I don't fucking care that I have to write dot, char, at, blah, blah, blah. It's just too little. I do a bajillion casts and the new whatever instance of test that lets you pattern match the guy after. That one helps a lot. I have been using the IntelliJ button whenever they come around that says do it. I've probably done 200 instances of it already. Makes the code a lot shorter. You know, it subtracts a line every time I do that. So it's shorter and cleaner and more obvious. Yeah, that's totally worth it. Nah, otherwise, I'm probably writing code that could as well been C++, except like I said, I like my safety. I'm mindless about it here. I'm trying to solve another problem.
We use Kotlin and Gradle, and that's it. Everything
go.
else.
There's your problem.
Everything else for the proof of concept is Java.
You're using Graal, that's your problem.
Yeah, I had a problem, so I got Gradle. Now I have two problems.
Yeah, exactly. Exactly. Yeah. No, I failed. Used Gradle once on a large major project with lots of people. That was a disaster. I'll never use Gradle again. Fine, but that's a different rant.
Are we back to the build systems?
Yeah, maybe. I don't know. I'm just doing this right now. I'm just doing a stupid make. It's fine.
So, Alan, what was the concern with the char app? What I was trying to understand the.
Oh well, I mean, I'm just wondering because, like, I don't know. I mean, maybe I'm too much of a Haskell fan, but like, Haskell is advertised as being the best language compilers because it's
so
functional and you don't have to worry about memory, you don't have to worry about storage,
right.
Everything's pure, so you don't have to worry about side effects.
Okay, so let me roll down why I didn't pick Haskell. It was definitely a thing that could have been done. I'm not as comfortable with it. I don't know the debugging story so well.
Okay.
I am totally playing memory management games in the compiler because I intend to do so long term because I know it has a significant impact on the speed of the compiler, for which I don't know that I can play that game in Haskell. I definitely can in Java, although it's ugly. I had to boilerplate the shit out of shit that places you wouldn't expect. If I was to do this in C, I would have gotten that for free out of malloc and free. But to do it in Java, I have to screw around with object pools, and I have one for every class, and it sucks. And there's an interesting, significant performance gain, and it's hard to backfit those things in. It can be done, but it's a pain in the neck. Yeah, I know. I've read these things already. Yeah, exactly. So let me know what your dog thinks about it. That being said, maybe Haskell could have been a reasonable choice. I wasn't as comfortable with it as I am with Java, and I am playing low-level memory performance games already. Fine.
Someone asked me this at work the other day. They were like, "What programming language do you use for like all of your normal programming stuff?" They're like, what's your favorite? And I was like, "Well, they all kind of suck, but I use Python because it's the runtime I've worked on. Like, I worked on 3 different Python runtimes, and it surprises me the least. And like, sorry, maybe ecstasy is the solution to all of this, but like,
yeah, that's fair. I want the strong typing I get out of Java, so I don't want Python. That was a non-starter for that piece. Haskell, I'm not as comfortable with.
Have you heard of our Lord and Savior Mypy?
In fact, I have. They come knocking at my door in their suit and tie every other week.
So one idea I do like from Mypy is allowing you to put types in a different file.
Oh.
So if somebody gives you a thing that's not particularly typed, you can be like, I am going to type this for you, but not change it in a way that is going to break it the next time I pull.
Yeah. I played that game in the land of JavaScript, where of course JavaScript has no types, but a lot of people want them. So you have a separate file with types, and I want to type with types, so I have to grab this other file to get their types. And the two get out of sync, or you have to go ask for special, and you have to import. And boy, not having baked into language is a fucking pain in the neck.
Yeah, it's kind of like Mark Twain talking about the German trilogy he was reading. He was waiting for the 3rd volume because it had all the verbs.
Excellent. Yeah, just the go back and forth and get it all in line and synced up, just like sucked in practice for me. Yeah, I've written a couple sort of large GUI interfaces in JavaScript and in Elm and in variations thereof with TypeScript and FlowScript and whatever. I mean, FlowScript beat having just plain old JavaScript for sure. But grabbing your third-party libs and getting the types out of them was like
I think when you're prototyping, you reach for the language you're most comfortable with that has the combination of that comfort plus the turnaround time, right?
Yeah.
Because nothing else matters other than iteration time.
And by God, I'm iterating.
Yeah, so Python I think is a brilliantly good choice.
Yeah.
I think if you know it, Java's a great choice. Java, Kotlin, Scala, I mean, whatever you know, C#, they're all the same. Like, sorry, Theodore.
What? Oh, why? Scala is a perfect language for implementation.
Oh,
Quick.
I meant they're all the
turnaround.
same. I meant they're all the same language.
Oh,
Yeah, Scala and C#, they're just about the same.
no, they're not the same.
We gotta find your hot button somewhere.
Yeah, Scala has a maybe the
Have
frontier
you met
for
Mypy, our Lord and Savior?
no.
I mean, Scala's just link, right? That's all it is.
What?
It's,
What?
you know, link.
Link? Hey, with the advent of the Scala native, I believe the Scala will be much more development and more serious application. That's
And
required.
this year's the year of Linux on the desktop.
Yeah, exactly.
Sorry, I don't mean to pick on Scala. I have no experience with it. I just am filled with jokes this morning.
No, Scala is a terrible language, and it's a perfect language for the job. So
I didn't pick Scala because I had all kind of warnings about compiler speed turnaround.
Yep.
Okay, that's why I didn't pick it for an implementation for AA.
Yes, the Scala is notoriously known for its slow compile times.
Yeah, right.
It's the motto for the Scala compiler. We go slow.
So slow build times are bad. I've also had frustration with unpredictable runtimes. That you'll get really good 99% time in some Scala programs, but then the 99.9 is 10 times larger.
Yeah, but who cares for prototyping? Like if Python's fast enough, anything's fast enough.
Yeah. Okay. Yeah.
Okay.
Yeah.
No, not anything, but anything but ecstasy.
Right. There's overheads for testing that I want to not be insane, but if they're unpredictable, that's hard. Like if I can dial a knob on my testing costs, I'll keep it at a reasonable level, trade-off testing coverage versus cost. But if
I concur with Cameron. You should pick the language you feel most comfortable. Usually the first language you start to program in.
Definitely not my first.
Yeah. Okay. But usually is the first because you're most comfortable with
Z80 basic.
Oh,
6502 assembler.
There you go. And then pretty soon Z80 assembly, and then 6502 basic Mac, Apple to be, and then the assembly, and then yeah.
mean, with the higher level languages, the most object.
There were no higher level languages for 20 more years. What are you talking about?
Okay.
Pascal, Smalltalk, come on.
Smalltalk,
Boy, Smalltalk was a thing I wanted to lay my hands on. I was in love with the concepts and the, what I could read and see about it, but I couldn't ever get my hands on an implementation. So that was definitely an inspiration for me.
When was this? Might I ask?
But when was Smalltalk, or when was I?
I mean, when did you hear about Smalltalk?
When it came out, the early 80s.
80, okay. Because I think
followed by the Smalltalk books.
Yeah. Because as far as I know, it took their time to get it to run on our personal computers and such.
It was only the Xerox labs forever and a day.
Yeah.
Right.
Yeah, in the 70s, they had the custom hardware that they built.
Yeah.
Right, Dorado.
In 1980
then
version, it was what got ported eventually to the PC, and I think that wasn't running until 88 or so on the PC.
That
when
could
did
be.
they?
I was well enthralled with it before 88, and by the time 88, 89 came around, I was sort of already doing language implementations of shit I could get my hands on and do things with, and I wasn't kind of set Smalltalk in the back of my head as a goal to get after making a language that did something like that.
Modular was popular. Modular 2.
Yeah, and it never struck me. Like I saw it, I messed around. I did a Pascal implementation. I wrote some code in Pascal in my implementation back in high school. Kind of bulky, it was okay. Turbo Pascal came out, kind of turned my head around the value of a good IDE. Made the language hugely better to deal with. Suddenly it was
You
like,
had an
it's not
IDE?
Turbo Pascal, absolutely. You had an edit, you had a run, you had a, you know, debug kind of things. Holy shit. And fast, way faster than anything people got now. And only a handful of keys that IDE took over that you use to get, so you didn't have to memorize 2,000 keys that did all kinds of shit that you actually didn't ever care to do.
So people rave about Smalltalk and Scheme and to a lesser extent TCL. Why are these languages falling out of favor if people were like, oh, I was so much more productive back when I was a Scheme developer or a TCL developer?
No, it's just there's definitely an overhead. Like if I looked at my productivity levels writing C code with GDB and Emacs, and I look at where I spend my time writing, debugging Java with the IntelliJ, there is an interesting fraction of my time, very thinly sliced throughout, where IntelliJ eats cycles that are junk that I don't have a way to not do. So I have a bunch of windows and a big monitor, that's great. He changes focus on me when I whip up the debugger and on and off and back and forth constantly, which I can't undo or predict without taking my hands off the keyboard and touching the mouse. So that costs me half a second to a second. Every time it happens every fucking time. So roughly a third of my time is undoing stupid shit the IDE is doing with just like, I went and touched the fucking mouse and I should not have had to touch the fucking mouse. So the penalty, if you've never gone no mouse for serious productivity, you probably have no idea. Yeah, Simon, there was enough conflict on the attendee list. I'm not going to do it. No worries. There is a heavy, fast, whatever. There's a much higher level of productivity. There's a less brain drain involved to not have to touch the fucking mouse, because you have to like move your eyes away from your focus point, find the pointer, move it to where you want it to go, and click something, and then you can get your hands on, refine the keyboard and go again. Get rid of that. I don't know how to get rid of that in any of the modern IDEs, but I don't have an IDE that works with Java. GDB like sucks with Java for no good reason. Java and GDB like disagreed for stupid things. I don't understand. So I can't go to an Emacs only GDB and Java setup. So I have an IDE, and the IDE plays mouse games that I can't really dodge.
And I think IDEAS changed that sometime in the last couple of years, because I don't remember the debugger stealing the focus until recently, and it drives me freaking nuts every time.
Okay, thank you. So I would love to have a version that said, thou shalt never take the focus off the editor page where the cursor is under any circumstance, unless I use a mouse.
Yeah, if I'm using a keyboard, don't ever change the focus.
Don't ever change the focus. Yeah, and I have totally been the case where I'm busy typing, like I've seen the crash, I know what's going on. I'm busy typing the next response. It flips, I'm now on the debug screen and I'm busy typing commands to the debugger.
Yep. And when you're in that screen, whatever you're typing, it thinks is a find string. So it creates a little window at the top and it's putting the characters across. It's like, where am I typing? Yeah.
Yes, right. Yes, you lost where you're typing with. The other thing that pops up is I have breakpoints set in all the places that say like unimpl, you're going to die here. So breakpoints. Okay. Well, all the broken things that want to toString themselves in the debug window, hit those breakpoints. So he pops up a line that says, and I skipped the breakpoint that I hit when I tried to toString, wiping out the line where I want to see what the hell I'm trying to read until I wave the mouse over the warning, the yellow warning box, and then it clears and I can see behind it. So I must, in order to see my debug window, wave the mouse, not click, to go see the shit. It's like, oh, come on, folks. Like fucking you skipped a breakpoint in the toString in the debugger. Okay, don't tell me. You called toString on purpose. I didn't call toString. It crashed. Okay, don't bother to tell me. I don't fucking care. Jeez. And some IDE, I need an IDE lover or whatever, IntelliJ, fanboy here to tell me how to turn these things off, because I would just, in a heartbeat, make my life so much better. Turn them off. Yeah. Ranting on IntelliJ.
Go back to
Are you-
look at it.
Okay, I remembered my real question, which I had for this. So the sea of nodes representation. So I'm working with like this weird graph representation. And so like my problem is I don't know how to look at it. Like I have the code that
Yeah.
implements the graph.
Yeah.
And like the question is like, how do you look at it?
Yeah.
Like how do you debug it
Yeah.
and figure out whether you're looking at the right graph or whether something
Right.
went wrong?
So this has gone on for 25 years in the land of Hotspot. Every new compiler engineer that came through went through this set of things, of phases they went through, where they stared at it, they didn't understand it, they couldn't understand how to interpret large things. They attempted a graph pretty printer. I did this as well, but almost every young junior engineer came through, implemented or grabbed somebody else's and tried it. And it kind of helped you understand the intuition in your head. But as a day-to-day operation, you quickly, like, it was too heavyweight to deal with. You pretty print with a fancy printer, one line per node in the IR, plus or minus indentation or grouping for basic blocks or functions or whatever you do. One line per IR node. Usually mine looks like there's a unique ID number. There's a short string fixed width, so they all commas nicely as an ASCII to the ASCII table of the node type. There's a list of input arguments. There's a list of outputs where they go to as node numbers. There's something custom for that node on the end, like constants, put the constant value they have. So I'm node 1, 2, 3. I'm a con node. I have no inputs, or I have the global start input. I have 15 uses. I'm a constant for the integer 7. That's the kind of thing. Oh, hey, Keith. Yeah, no problem. I've tried many variations, and I've met other people who've tried many variations, and the answer is, nah, that's the right thing. And then there's a printer that you use from the debugger that has print the guy I'm on with the 2 strings. The debugger pops it up normally anyhow. Print to a depth of n, where n is fairly short, a breadth first or depth first. I don't care. One of these print versions that says do n. You put in for 99 or 999 will give you everything anyhow, and you don't care anymore. Sometimes you want to print the reverse direction. I have a couple of variations of pretty printers, but the typical answer is they do 1 line per node. Some of them group by basic blocks and functions with function headers and tails neatly. Some of them do indentation accordingly. Some of them do reverse prints. Some of them do control flow only. So 3 or 4 prints, but a print, an ASCII 2D table output, basically. Okay. And the other thing I end up doing a lot of, if I have something complicated and subtle going on, you get this.
So you actually draw the
if I can't figure it out in my head and I can't stare at the ASCII print, I'll stop and spend 15 minutes drawing a pretty thing, annotate the fuck out of it, and usually somewhere in the middle of drawing that, I'll like snap, oh, this is what's going on. And then sometimes I finish the diagram, because then I'll use it when I'm debugging to finish the correction, make sure I get the correct version out. And then, then you throw the big hammer test suite at it and go on from there.
Yeah,
merge mem, there you go. Yeah, that's a correct big bad one. 502 merge mem. This has gotten longer name strings. This is in the chat from Zen. This is a hotspot. Triple equals is going to be a separator saying, and here's my inputs versus outputs. Oh, that's a big merge mem. That's a big one.
Can you put that in the doc? I'm having trouble looking at it in the chat.
Yeah. So I can break it down what it's doing, but this is a big one. Merge mems. This is like an ugly one.
Yeah, I deliberately, I just want to put this on purpose, show that, each one-liner can be very long and very complex. Actually, this is like a table,
Right.
The left is index, the right side is all those aliases.
Let me see if I have if I can get, I'm all higgledy-piggledy. See if I can get a more reasonable version of an example here. If anything will run, of course, I've got everything killed here at the moment.
Yeah, I mean, so what I have is I have a graph. I basically dump it to a graphics file, and then I visualize the graphic. I mean, it works for small examples, and it doesn't work as the example gets large.
Right. The print works as the examples get big because it's a lot denser, and you can chop it to the local area by putting a cap on the number of things you print. So I usually make these very short. So my top level dump of the entire graph is aa.p. Okay. Then I have a find call that go finds a node number, aa.find or f of a node number, followed by dot dump and then a cap of 1, 2, 3, 4. It's usually pretty short, or it's 99. Then there's optional versions that say also dump the primitive nodes, which are basically unchanging and fixed for all time, and they're boring to look at. Also dump more information like reverse flow, forward flow, blah, blah, blah. But those are all optional overloaded flags. So the standard dump I do is I'm looking at a node in the debugger. I hit Alt F8 to bring up the expression syntax. I say node.dump3. And then I tab into the debug window, hit Control C to copy all. I Alt tab to Emacs. I bring up a blank buffer, which is another 2 character strokes. Hit Control Y to dump. I get a big sheet of that dump and I stare at it in Emacs because the dumper in IntelliJ is stupid. I can't stare at it conveniently. That's the common thing. Right now I'm so broken I can't run. I'd have to shelve everything and roll back a version. Then I could get you the current looking AA dumps. Zen picked a bad one on purpose. They can be very long. The typical one though is, not the width of the single line in the chat. It's going to say 502 add equals number left, number right, brackets for the reverse, the use case. There's probably one user for that. There's nothing after it because it's got no special whatever to say. Merge mem is looking at all the alias categories in the universe that the JVM knows about at the moment. And it says I
put it on purpose. I just want to show that actually there are like 2 tables in this one single node. One table is JVM state. One table is JVM state. Actually, there's a table to so that you can see that there's like a stack unwinding part for the JVM. The other table is a map of different node, different input maps to the different aliases, memory slices. This is an extreme case. But for those scalar operation or arithmetic operations, it's very easy. It's not very hard to understand.
Yeah. I like it. It's really sad, but I can read this thing fairly clearly, although I haven't looked at a hotspot internal dump in 20 years, 15.
Oh, my guess is, when I read this print, because, you put this in certain format, my guess is you copy and paste it in the Emacs buffer and apply some kind of list script to format this one to some kind of like easy understanding representation.
No. I will usually cut and paste the dump as a 2D table into Emacs buffer. And then if it's big and complicated and I need to know something else, I might sit there with Emacs macros and reformat it a little bit. I usually do not. Usually I arrange the print of multiple nodes to come out as a nice, easy to read 2D table on purpose, because that's a common function. So if in GDB, I would have said, got somewhere, I have a local variable, let's say this.dump, and it's already an Emacs buffer from GDB inside an Emacs buffer, and it would dump a 2D table in the buffer right in front of my face, along with the entire interleave with the debugger activities. So that was a really convenient way to see state and time as I moved forward, just roll up and down the buffer to see it was like this, and I did this step, and now it looks like this, and I did this step, it looks like this. Oh, I'm getting close to the bug, and whatever. It's very convenient. The IntelliJ workflow is a lot less convenient. I'm staring at the IR in my Emacs buffer. I Alt tab back to IntelliJ. I step forward. I have to generally Alt F8, down arrow, bring up the print, hit the enter, tab, Control C, Alt tab, yank back. It's like a dozen keystrokes. It's way faster than mousing it, but it's still a dozen keystrokes to get the next version dumped in front of me that I can see the progress as I'm going forward. That's the current workflow I have. I hate it. I wish IntelliJ would give me a better dumper, or I wish Emacs would integrate with a Java debugger directly. that would make my life easier. One of the key things here is that putting the text into an Emacs buffer as opposed to an IntelliJ buffer gives me all the search capabilities that Emacs has and all the reformatting, reflow that I want that Emacs has, that I have special custom for this kind of shit. I do have those things, I just don't need them very often, but when I do, they're just right there. Compare windows happens, like I can whip up 2 of these dumps and in a handful of keystrokes, compare big dumps, and they'll stop at the different points and then step them forward to all the diffs. So it gives me a quick diff between things without having to pop more windows or not. And then Emacs buffers can come and go at the blink of an eye. You can just hit one button, make it go away, make a new one, make an empty one, clear it, whatever. So that's the workflow is Emacs gives me an endless supply of empty template places or blank notepads that I can drop things in, take things out, boom, 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 boom. And I do that to compare and look at and diagnose these kind of dumps.
Yeah, I just want to call out that there's like a couple of special nodes are really complex. One is the merge node, a merge memory node. The other one example is a save point node, because save point nodes, the inputs of save point nodes contains all different types of information, and you know, they have different meanings. So usually one save point node have like maybe like 50 to 100 inputs, and you have to decode them because you know they come in certain order, and there's some meaning for different orders. And you know, it sounds like a plugin could be very helpful, you know, to help you to visualize those special nodes.
Okay. So if you have handy, would you give a larger dump of normal nodes, not merge mem, but just straight up sort of I'm doing array math kind of shit nodes? It would be useful to look at. And the other thing is that it sounds like you're in that point in your cycle as a young engineer working on Hotspot is you want to try a graphical thing. And like I said, everybody I ever know went through this phase where they tried a graphical thing for a while and they went back to the ASCII dumps after a while. But you got some intuition about what was going on in the graph. And then you got the intuition and the graph thing was too heavyweight.
I believe the problem is with the representation of the graph. There are just too many nodes to visualize. There has to be something like Google how to scale at the scale you're looking at, something like that to capture the.
I've done compilers forever and a day. There's you have to have a large count of tuples in the graph. There's just no getting around it. You end up, roughly speaking, with a tuple for every piece of assembly code that comes out, and more tuples at control flow splits and joins, and more tuples in the case of Hotspot Java for doing save points, which are a complicated concept, at least at the low level. So I don't know that there's any way you can get away from having a lot of graph. You don't need to look at it because it's correct generally in these small sections. So you don't need to look at the whole thing all the time. So I'm sorry, Max, you're trying to say.
This is related, but not immediately in the conversation you're having. So
go ahead.
I should interrupt in the middle.
Go ahead.
So I'm looking at building perf tooling for large Python applications. Mostly it's going to start as surfacing hardware and software perf counters in some readable way. But if you have a large number, say a bazillion lines of Python, and a large number of servers, say a bazillion, that's the most specific I can get. And you have a large number of web requests, say a bazillion. These counters add up.
Not to mention Facebook or anything. But
no comment.
Okay, to record the perf events and somehow.
Sorry?
To record the perf events and somehow to visualize them, like a flame graph or something.
Exactly. I'm not looking at a flame graph just yet, but I'm looking at like, well, if we have 3 million deopt events, like it's an interpreter side exit, it's not a full like function decompilate or whatever. How do we surface what's important to compiler writers, which is different from what's important to end programmers? And how do you make sense of that? And some people are like, well, you know what, you should use, you should put LSP, you should emit LSP, whatever, so people can see in their editors this information. I'm like, yes, sure, but I don't use VS Code. I can't be bothered to learn it. It's too late. I'm, in my old age, I'm stuck. So I'm going to keep saying shit like this. It's great. I get a reaction every time. So I was thinking like, well, okay, we should have two representations for offline. One of them is like a dump, an HTML dump of the annotated source that can be clicked through. It's, you can see, well, this Python expands to this, these IRs expands to this assembly, and here's how the perf counters affect all the way through. And then the other one is, you got me thinking now about an ASCII representation of this dump that's navigable. You the Vim jump to definition with like C tags?
Yeah.
You can C tags your way through it and do that. Which sounds like not a bad idea.
So both are useful. One is I am staring and thinking, but I'm open-mindedly exploring, and you want the graphical click-through. One is I am just on the edge of wanting to run a tool to gather a very specific kind of thing, and I'm diagnosing my tool and I'm diagnosing the situation. So I'm looking for something specific. So I've whipped in my editor and I have a search function rigged up, just Control F, blah, 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 regex, yada, yada. And I'm walking through this thing looking for counts of hits to decide it's time to, write an awk script or whatever the hell, and pipe it through some sort of next stage analysis tool, wherever I get that from.
Sure. There's a raw dump that's going to be probably some SQLite or something.
You want the dump that you can both stare at it with your eyes and interpret what the hell goes on, and relatively conveniently search it with semi-automated tooling like editor searches, regexes, and awks. Those are the one that's the raw dump has a different place in life. It's storage. It's a big, heavy effort. Parse functions are going to do big things with it. It's dense because you have a lot of this data floating around. It's not, human readability is not one of its key aspects. There is a version that wants to be human readable where the human has reasonable quick access tools. And then there's the human readable where there's no tooling, I'm just surfing the web. Right? So you want that middle version that says there's an ASCII human readable. So you want like the fake 2D table variant where I can, whether you do alt tags or where you do Control F searches or whatever, you have some quick navigations going around. There's definitely a use case for that version. Anyone doing deep analysis will be in that middle space a fair amount until they know what they're looking for. Then they might go to the big heavy tool that says, eat the terabytes and petabytes of the shit you've accumulated over the years and run this analysis and count. Oh, we de-opted here 1 bazillion times and add the following 10% latency to the click through of blah, 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 page reload, yada, yada, yada. What I could find. But you don't go though first. You're just like, what the hell is going on here? Who matters and who doesn't?
Yeah, the goal is like, okay, well, can we see type profiles at this PC in different layers of the stack? Can we see call counts? Can we see deopt? Can we see?
Yeah, at one point I have.
So how do you get from those control level counters back to the line of source code that it's talking about?
So did you say how?
You can, but you should. I'm assuming you do.
We can. I mean, I think I'm going to need to add like 20 lines of something or other. But right now, I think it's going to be pretty straightforward to map from our, well, assembly, I don't know. We can probably add, we're using asm JIT, and that probably has some kind of annotations feature.
You don't have to go from every line of assembly back. Like in the line of Java, every safe point will go back, including all layers of inlining and the like. But between safe points, which is typically 10 to 1,000 ops, it's a pretty big spread. There's no direct map back. Disassembler will reverse engineer offsets to field names and shit like that, but just periodic is good enough.
Yeah, so that might be the move. But to LIR back to HIR, we can do LIR to HIR and HIR to maybe bytecode, and then Python has some facilities for bytecode to source. But I want to make sure this all works smoothly so that you can just click around.
Yeah, the high level surf version wants to go back to Python, and your application writers will be terribly interested in how that goes. you'll get some of that as a compiler writer, but then you'll also want other stuff that you don't ever make it back to. You're just like, time went here. What happened? Oh, this stupid thing. It round and round, deop, recompile, deop, recompile, reop, recompile, blah, blah.
Yeah, and there's a couple different use cases. One of them is like, oh, we shipped this thing. Why didn't the compiler optimize it? We missed this. Fine, great. Like we can see the generated code all the way down. Okay, it's specialized now. The other one is like, what perf counters are telling us things that we didn't already know? Like why, like, oh, this is a hotspot because this function could be inlined if we did something else to it, but right now it's not, and therefore it's megamorphic because whatever.
Yep.
And so like I want to get that kind of thing.
Yep.
But like we shouldn't ever surface that to end programmers because we don't want them modifying the code in a way that will not be relevant as the compiler gets better.
I went round that path when I showed off the Azul VMs with that JIT showing assembly. It was incredibly useful for end developers who didn't want to wait for the compiler turnaround to get there. So mostly it was done by intelligent developers who had enough brains to know what they're getting into, but couldn't wait for the next. I mean, this is also Java wasn't on the 6-month training cycle. Didn't want to wait 2 years for a JIT improvement. And they could immediately see stupid shit was going on here. Okay, I can hack that. And they would hack it at the Java level and make their lives better. So I claim don't try to defend or protect the developers from hacking their code because your JIT sucks. Yes, your JIT gets better. Yes, they have their own lives and their own decisions to make. If they choose to warp their code to make it better right now, that's a reasonable trade-off in some circumstances for them. Don't
Largely,
play
we're
daddy or mommy
for that kind of thing.
Tell them don't do it.
We're like code gardening to do that, and I think we should be, or whatever. I don't know if it should, but we are, and that's our responsibility right now, not random Joe Schmo Python programmer.
Have you read the Google ASMDB paper?
Google what?
They have a tool they call ASMDB, where the idea is they're monitoring the actual assembly that is being executed on servers so they can get some performance counters and be like, okay, where should we spend our time? Is there one particular page of YouTube code that if we make a little bit more performant will save us $1 million a month?
Ah, yes. So this is the kind of thing that I also
Put
want
a link in. I heard that one.
surface the hardware counters to like actual high level concepts. Yes.
I put it in the doc as 11.
Interesting.
But yeah, they were very much, how do we go from this is the assembly running on 100,000 computers to this is the line of code that we want to stare at real hard, because if we can move it from 3 instructions to 2 instructions, we're going to save a lot.
In technical terms, $1 bazillion. Yeah, exactly. It's like, I want to see.
I was going to say the bazillions you were saying earlier are orders of magnitude apart.
Yeah, that's one of the things that people get a little twitchy about, and I don't want to talk about.
Yeah, I've had talks where it's like, this is a distributed system involving more than 2 servers and less than 2 billion servers.
Yeah,
like,
right.
Okay, great.
Your name is Google, so that number is pretty big. Yeah.
You know, yeah, exactly.
Like more than a decade ago, I knew that Google was running more than 1 million servers running Java. So I don't know what it is now, but I'm sure it's not smaller.
There's at least 5, you know.
5 million or 5 Googles. Never mind.
At least 5.
At least 5 servers. Yes.
Yeah.
Well, like I said, I already knew it was more than 1 million and more than a decade ago. So it's probably more than 5.
My team's at least 10 people, so we've each got one, so it's at least 10.
Yeah. Gotcha.
That's the great argument when you go back and look at the papers on Byzantine fault-tolerant systems. And they're like, this is a distributed system with at least 5 nodes. And now people are like, okay, I want to do this Bitcoin style with millions of... And you're like, yeah, it is not surprising. You need to tweak this protocol that was designed for 5.
Yeah. All right. Oh, I was going to throw out, I kept for the longest time a dump of a hotspot debug info for producing what Zim just pointed up here, all the reverse back to architected machine state for Java state from machine code. And I had roughly 1 million such dumps that I threw in a big text file, and I did a bunch of analysis on to decide what kind of compression and representation strategy I wanted to have. And custom tailoring the representation strategy for the kind of debug info you emitted was worth, pretty good sized numbers over what you got out of like gzip. You only needed that information rarely when you took that DOP path. So you wanted it kind of compressed, and you had a shit ton of it. So you did want it compressed, but there were things you could do, because like null for uninterested and unusable values was really common. So you had to have shortcuts for sequences of nulls, and many things were null or not the null or whatever, and how to exclude left and right. But then you had to go deep and say, here I have to have constants, and here I have pointers to objects I have to go manifest on the fly, and all kinds of stuff. Fairly complicated representation, but amenable to a lot of compression. But it all turned into exactly what you get out of your performance profiler. Where did it happen? What's it look? How do I reverse this counter location to some source code level? That was all something to be done, where you gather a lot of them and then stare at them with some sort of statistical analysis and decide how to compress them. Well, that was all I have. Has anyone got anything else? We are 2 hours long. A lot of folks are yawning.
Well, just one question, which is sort of, I'm thinking about using a sort of, what would I say, runtime profile analysis for another compiler project. This is for regular expressions. So like, say for example, well, yeah, that's a problem. The other problem is I end up with a bunch of tight loops. So like, say for example, a common hack is that, say if you have one that starts with a constant string, and then you have, your rest of your crap after that, you use your favorite string searching algorithm, you use your sim, you use your boy and more, whatever, use that stuff, and you just search for the prefix. Then once you get that hit, then you go for the rest of the expression. So that's one sort of tight loop. But I'm trying to attack a more general sort of case. Say for example, maybe we have a quote, and then we have, say, not quote, clean star, quote, and that will, match stuff in quotes, say, for example. The problem with that is that I've come up with 2 ways to do it. First, I can just write a tight loop where it's like bump the index, compare what's here. If it's the same, go back in the loop. Otherwise, go out of the loop. I can do it that way, or I can use the simmed. Again, I can use the simmed instructions and check a whole bunch at the same time. The problem I found is that for short matches, say, for example, one I found was, say, screen resolutions would be 3 or 4 characters most. We don't have big screens. And that's slower to use the sims. It's like, I want to maintain this information. I want to get it pretty quick. I'm not sure how to go about it, though. I just want to know which to pick. And I think there's correlation, if you have a short one, you tend to pick short. If you have a long one, you tend to pick long. I don't know how to go about this, though.
So you pick something correct and works reasonably well, and don't get complicated. So skip SIMD for a minute. Get that working everywhere. Decide that these loops are actually in your face, that they're actually performance matters.
Yeah.
And you can start to play the game of, I'll put a pretest in that asks the loop trip count. I'll go left, I'll go right, according to whatever, or I'll profile and say that at some point, sometime in here, periodically, I'll reset the generated code and rebuild it based on profiles collected over time. But get yourself correct, and then show via profiling that you care to do a SIMD thing.
Yeah.
Because a SIMD thing will at best buy you like a 2x on string regexes if they're just very specific kinds of regexes. So you're not talking huge amount of time wins, typically in the grand scheme of things. Regex is not always at the top of the charts. In fact, it's rarely at the top of the charts. But if it is, you do, and then you screw around. But I would start with go simple, go stupid, go easy, make a tight loop. come along later and say, if I put a pretest in, I can catch a couple of these cases where I've got a giant ass string and I need to SIMD my way to the end. And then I can, bail out offline and go write the SIMD code and deal with it, as a one-off case or whatever. As soon as you have a giant loop, you can get away with all kinds of other shit. Like I'm going to bail out to like a C routine that I write C code for that's going to SIMD the hot inner loop, knowing already that the trip counts 1,000,000. So if I spend 100 cycles or 1,000 cycles at the beginning, I don't fucking care getting my setup. Hey, I'm going to do cache line alignment. That's going to be way more important than half the SIMD things you'll do anyhow. You do a bunch of stuff. As soon as you say the trip counts 1,000,000, I got a lot of time. You screw around, get your life easy. But you're generating code, generate the easy shit that you want to run well and generate it fast and simple.
I mean, I've done that, and there is about 2.5x for such loops. Yeah, that's
okay.
What I've got. Yeah.
Then I would put a pretest in. I would not go to the profile and rebuild unless you have enough nesting that the profile lets you specialize in different cases. I would instead say, this loop occasionally sees big trip counts. Do a test. It's got a big trip count. Jump somewhere else where somewhere else can say, make a call back into the C runtime. I already have a big loop. I can take some time to set myself up and, go out that way, including jitting SIMD if you need to, but just calling out to a routine that's well written that's using SIMD to spin down a big ass array.
Mm-hmm. Yeah, and also like, should I keep the whole count, or should I just keep a less than, greater than flag? Or
generally, it doesn't hurt you to keep the whole count, and then it's useful. As you go forward in time, you're like discovering new things about what's going on. Keep the whole count.
Okay, thanks.
Mm-hmm. All right.
Okay, one last question. So, all right. So I mean, there's sort of this design question is, do you write a JIT or do you write an ahead of time compiler that could use profiles?
Why is this a decision between? Obviously, Hotspot does them both.
Depends on your use case.
No, I'm asking. Okay, yeah, then exactly that's the answer. Depends. Like Hotspot has some things are kind of ahead of time. A lot of things profile than JIT. We don't have the Azul guy here. I can't remember his name now. He all the time is doing ahead of time with profiles for high frequency traders who gather profiles over time and then want to pre-JIT the code. And they might JIT again after they gathered more profiles while they're running, but their first cut start off is, we took this profile data from yesterday's execution and we ahead of timed it. So when the trading day starts, the first microsecond I can trade, I'm running at least ahead of time JITted quality code. So
that's one of the things that makes me reach for the model of, can I essentially hibernate my VM or take a snapshot where I can let the thing come up and do its JIT and run through a whole bunch of sample emblematic data. And then once it's warm, take the snapshot and deploy the snapshot rather than deploying sort of the beginning of time.
I've done that for non-Java, not for Hotspot, but yeah. Hotspot has Java has weird startup issues unless you do exactly what you said, and I'm going to start up in the middle. You have class loading has strong ordering, and you've already JITted code that assumes classes are loaded, but they haven't been loaded, so you can't reuse the code directly unless you claim I snapshotted the heap to the down, and I'm bringing up the heap again, and that's just I did a virtual machine thing, and I put the damn VM to sleep in a virtual machine, brought it back up.
So you think that there's really a space for, I just kept the counters so that I could ahead of time things, but I didn't keep my old heap.
I totally think so. There is an
That's
easy,
what we do.
Yeah. Okay. Yeah. I think there's a space there. There's an easy thing that says I just use a VM, AWS image that I snapshotted the VM running, and then I brought up the snapshot over and over and over again. There's another one that says I just took the profiles and kept them down, and I used them to pre-cook some code and pre-initialize my stats when I'm running with the JIT. And what I heard, Alan, you say is I have to pick between the two. And the answer is however much engineering time you want to spend at it. There is a first choice you do, and then there's the next step.
All right. So,
well, you want to do a profile JIT up front?
I mean, it's not like it's an either or.
Well, that's what I'm pointing out. Yeah, you said either or. I'm saying no, it's both. Which one are you gonna do first?
Yeah, probably the profiles. I like fast code.
Okay.
I mean, with a JIT, you have to make the decision of, is this worth optimizing? Do I have enough time to run this analysis?
It's actually it's a very simple equation.
Yeah, but with ahead of time, you could just run. You could burn as many CPU cycles as you want because it's all compile time.
Yeah.
Well, the nice thing is also the profile is portable.
Yes.
Yeah.
Reasonably portable given your workloads, but in your case, I think very portable. You have many similar workloads repeated across many machines.
Sorry, what I meant is like if you have a class file and a profile for that class file, you don't need to recompile the profile for like ARM.
Right. Oh yeah, for different
It's
backends,
just-
certainly not.
Yeah.
Well, I mean, that depends on how you design the profile. I mean, you can have a architecture dependent profile.
Whenever I was doing profiling, I was profiling at the semantic level.
Okay.
So I had a map back to the Java. Now it was important to have inlining on the profiles. But it wasn't a different profile for x86 versus ARM, but it was definitely different if you inline left or inline right. So pick some trivial level of inlining you think you're going to do anyhow and specialize your profiles down those inline paths. That was definitely useful. So I didn't actually do it what I heard Max say with per class. I profiled what the JIT, I profiled once in the interpreter and once again in the first tier compiler, which had inline decisions from that interpreter. And then I hang around to profiles that were based on where hotness showed up. That you could have done it. It wasn't per class per se, but it was class with inlining. So I did have the class. So it wasn't not per class. I went in a few layers.
That was just meant to compare and contrast class versus JITted code.
Oh, JITted, yeah. But the semantics were done at the Java semantic level, not at the machine code. Like you also got, and I didn't hang on to these profiles, I could get L2 cache misses, L3 cache misses these days, whatever, cache misses, which would point to loops where you had poor locality. But those didn't have a semantic back to the Java data structure where you had a setup that was leading to bad locality. And that could have easily been the majority of your time spent was chasing cache misses on data structures with bad locality, but I didn't have any map back to the code that was running it or the class data structure where it came from.
That's the one thing I don't have a solution for my profile, and that's okay, not the one. I have a lot of open questions, but like iCache and dcache and mapping that back to like
iCache I could map back. iCache I could map back.
Really?
Yeah, because you had a PC. PC went to a piece of JITted code. The JITted code had landed in the middle of between two safe points. You were somewhere between these two architected machine states for every PC. I needed.
But does it mean anything like helpful?
Yeah, it told me where the hot loops were, hot code, hot time. This is random stack sampling, but I also did ones where I took iCache misses, but I got a PC out of them. It was an Intel iCache miss. They have one of their things you can ask for. I took an iCache miss. I got a program counter for it. That every program counter got reversed back to basically Java source code with inlining layers and shit like that. Data structure misses did not. I could have, I didn't do it. I could have told you the class of the object that you were missing in, but usually you had a cascading misses in a row of some set of things. I had a big array of a bunch of linked list things that I went down the list every time because a foo contained a bar, contained a Z, and I have to get down to the Z to compare and say I got the wrong foo, go on to the next one, whatever, fuck, I don't know. People did stuff. So you got a streaming series of misses out of these things, but I didn't really have, I could have told you the classes, but I couldn't tell you the relationship between them or the code that generated this relationship such that you had suck-ass locality, which was still yet again far removed from how you'd remap it to get rid of the locality problem. Yeah. So at that point, I went to, the human eye, said, oh, you're doing a lot of this. And let's also do Java code. Oh, your Java code's doing this. Rewrite it this way, and maybe life gets better. And, lo and behold, usually, but whatever.
All right, I got to run. This has been fun.
Yeah, I think so. I think we're going to call it for everybody here. It's lunchtime. All right, folks. Till we meet again. Bye-bye.
Bye.